Let's look at error intervals. An error interval is the range of values a number can take before being rounded. Error intervals involve inequalities that include the upper bound, so the biggest value a number can take before it is rounded, and the lower bound, so the smallest value a number can take before it is rounded, of a number. So an example, a number x rounded to the nearest whole number is 8. What is the error interval of x? So the smallest value that the number can take before it is rounded to 8 would be 7.5 if it's rounded to the nearest whole number, and that would be less than or equal to x but less than 8.5. To the nearest whole number, 7.5 rounds to 8. If we had anything less than 7.5, so for instance if we had 7.49, then to the nearest whole number that would round to 7. And so since 7.5 is the smallest possible value that rounds to 8 when rounded to the nearest whole number, then x is either equal to 7.5 or it can be greater than 7.5. So we could have 7.6 for instance to the nearest whole number that rounds to 8. And we could have 7.85 for instance to the nearest whole number that rounds to 8, and so on. The biggest possible value that rounds to 8 when rounded to the nearest whole number would be 8.49 recurring. But since that's quite a long number to write out, we use the nearest number after that, which is 8.5. 8.5 is much easier to write, and so in our inequality we don't have an equals. We have a strict inequality, and so x can be any number less than 8.5. So for instance, it could be 8.1. 8.1 to the nearest whole number is 8. It could be 8.45. 8.45 to the nearest whole number is 8. It could be 8.499999 and so on, and to the nearest whole number that would round to 8. If we had 8.5, however, to the nearest whole number that rounds to 9. Since it doesn't round to 8, we don't have equals here. It's a strict inequality. Let's look at some further examples. So the question says, find the error intervals of the following. And the first question is x to the nearest 100 is 1700. So we need to work out the upper bound and the lower bound to work out the error interval for this question. Since our number is rounded to the nearest 100, then our unit is 100. And so if we want to work out the upper and the lower bound, we need to plus or minus half of the unit we have here. So in this case, if we've got 100, if we half that, that becomes 50. And so we add 50 to 1700 to obtain the upper bound, and we take away 50 from 1700 to obtain the lower bound. So the upper bound is equal to 1700 plus 50, which is 1750, and the lower bound is equal to 1700 take away 50, which is 1650. We have the following. A number called x, which when rounded to the nearest 100 is 1700, can be between the following two numbers. The lower bound, which is 1650, and we involve an inequality, so this is less than or equal to x, which is our number, which is then less than the upper bound, which was 1750. Again, remember, we can have equality with the lower bound. So if our number was 1650, then that rounded to the nearest 100 is equal to 1700. However, with the upper bound, we can't have equality, since 1750 to the nearest 100 is 1800. It's not 1700. It can be any number less than the upper bound, but not equal to it. This tells us all numbers, whether they are decimals, whole numbers, whether they are mixed numbers, as long as they're between 1650 and 1750, then when rounded to the nearest hundred, they equal to 1700. For the second question, we're trying to find the error interval for when y rounded to one decimal place is 2.4. So in this case, we first need to work out the upper and the lower bound. And since our number is rounded to one decimal place, we know that for one decimal place, the unit would be 0.1. We go up in 0.1s when we're looking at numbers to one decimal place. Now, to find the upper and the lower bound, we need to work out half of the unit and then add it and subtract it from the number we have. So 0.1 divided by 2, or 0.1 halved, is equal to 0.05. And so adding 0.05 to 2.4 gives us the upper bound, which in this case is 2.45. And taking away 0.05 from 2.4 gives us the lower bound, which in this case is 2.35. And then finally, for our error interval, we have the lower bound, so 2.35 is less than or equal to y, which is any number that when rounded to one decimal place is 2.4, and our upper bound, so y is less than 2.45. So generally, if we want to work out the error interval of any number when it is rounded to the nearest 100, 10, decimal, or whatever unit, we can do the following. So for the error interval, we have that the lower bound of the number needs to be less than or equal to any number, say x, which is less than the upper bound. And this gives us the error interval for x.